Last class, we were studying that an interpretation function is something that binds formulas and models, right? And we also saw that the models reside in semantics land. That means I'm talking about a virtual land here, semantics land. Here it is syntax land, and here there are inference rules. So for the syntax land, we saw that there are propositional symbols. Propositional symbols. So propositional symbols may be anything like A, B, C, like this. Okay, and then there are formulas. Then there are formulas that we saw. So formulas were something like when symbols were connected together with connectives like and, or, negation, etc. Implies that, or uh, by implication, like that. So we saw these things. So they were residing in the syntax land, and then semantics resided in model, and there was a interpretation function that was binding both of them, that was connecting a formula to a model. So then we took an example. So for today's lecture we will start with an example. Okay, we will start with an example, and we will see that how machines do and reach a conclusion or do infer a formula. So here we will write formula f. It is given to us is negation of A and B and by implication of C. Okay, and we are given the models as A to be 1, this symbol has the value 1, then B to be 1, and then C to be 0. Okay, so this is the truth assignment. This is nothing but a truth assignment that is given. So how a machine will proceed to find the value of the given formula? Okay, it has to, the main aim is to find the value for this formula. So how it will proceed? Let us start from here. The first thing that we can see here is A, right? A, and then it becomes negation. That means I of A W is given to us as 1. We are being given that I of AW is 1 because here the value of A is given to be 1 in the model. So now if I move and if I try to calculate the value of negation of A, okay, so it will move like this, and then negation of A comma W, so this will become equal to 0. Okay, this will become equal to 0 because if it is 1 then its negation will be 0. Now see, negation of A is there with and with B, so I also need B. So the machine is already having the value of IBW, I, B and W, and that is given as 1. That is given to us as 1. So similarly I will have by implication with C, so I also need the value of C. So how I will be writing this? I of C comma W is equal to, it is given as 0. Okay, now let us connect them to derive the given formula. So the next step, what I need in the next step is I need I of negation of A and B. So I need I of negation of A and B. Okay, so what will be its value? This is equal to 0, this is equal to 1. So, and if it is and, then in and actually both should be equal to 1, then only the value is 1. So this will be equal to 0. Okay, now see, what I need to have is by implication of these two, by implication of these two. So we know that in by implication, either if both the statements are false then the output is true, or if both the statements are true then the output is true. So here both the statements are false and hence the output will be true. That means if I write the given formula I of negation of A and B, and then by implication with C, then then by implication of C and comma W, the world, then it will give me, this will give me the value as 1. Why it is giving the value as 1? Because both of them are false. Okay, so we knew that if both of them are false, then the by implication is a true, that means it is a 1. So this is how machine will start from these given conditions and it will find the value of the given formula. Okay, now let us proceed with another case, that is about, we will something see that what are models. Okay, so the formula that we are having, formula, they represent a set of models. Okay, they represent a set of models. Formula represents a set of models. That means formula reside in the syntax land and corresponding models are there in the semantic lands. So we can write that each formula, F and a model W and a model W has an interpretation, IFW, I of F comma W, and this value of IFW will belong to, it will be either 0 or it will be either 1. So this we studied even in the concept of interpretation functions, right? So this we studied there. Now let us define models. So what are models? Okay, let us define the concept of model. Let M F be the set of models, W for which I of F comma W is equal to 1. So M of F, that means model of F, is defined as, let M of F be the set of models W for which I of F comma W is equal to 1. So if this is from the syntax land, this formula is from the syntax land, let us say, and corresponding model, let us say this is our world W, and this formula is having a corresponding model here. Okay, and let us say this is represented like this, and this particular subset of W, is where I of F comma W is always equal to 1. So this we refer as M of F, that is model of F, right? So here M of F, I of F comma W is equal to always 1 for this model. So let us take some examples. Let us take an example and then it will be clear. So let us take the formula as F is equal to rain or wet. Okay, then the models, that is M comma F, would be such that the F is always, the interpretation function is always 1. So how we can represent it? Rain or wet, that means if either of them is 1, then my IFW will be equal to 1. So if I write it something like this, that means, let us say if I am representing here my wet, and it is, this is 0 and this is 1. Okay, this is 0 and this is 1, and then I am representing this side with rain. Okay, and this is 0 and this is 1. So if the rain is 0 and wet is 1, that means my IFW should be equal to, what it should be equal to? It should be equal to true, because either of them, if either of them is 1, then the output will be true. Here it is, for this region, rain is 1 but wet is 0, then also it will be equal to 1. Okay, and here both are 1, so again it will be equal to 1. So why it is like this? Because F is true only when at least rain is true or wet is true. F is true, F is true only when at least rain is true or wet is true. So here you can say that a formula basically compactly represents a set of models. A formula, we can say that the key idea is compact representation. So what this formula is basically showing? It is basically showing this particular thing, it is showing compactly. Okay, so a formula compactly represents a set of models. Now coming to knowledge base, the next term is knowledge base. So what is a knowledge base? Now we have defined models, then let us see the definition of knowledge base, or we denote it in a small by KB. Okay? In shorthand notation we write KB. A KB is a set of formulas representing their means formulas, their conjunction that is, conjunction is also said as intersection. So if I write the models of KB, M of KB, see the KB belongs to the syntax land. Okay, this belongs to syntax land, and M of KB belongs to the semantics land. So M of KB is equal to intersection of M of F, models of F, where F belongs to KB. Okay, so this is basically the intersection of all the models of F. So one statement is that KB specifies constraints on the world. KB specifies, this we will see with example. Okay, this we will see with example. So a statement that I can write is KB specifies constraints on the world. KB specifies constraint on the world, whereas M of KB, that means model of KB, is set of all world, set of all worlds satisfying those conditions, okay. So we are having an example here that I can write like this: let KB is equal to rain and snow, and traffic, okay. So this part is rain and snow, this is F1, formula 1, okay, and this part is formula 2, F2, right. So if I represent them like this with Venn diagrams, the sets, so this is basically F1, that means it is basically the model of rain and snow. What I am saying is this region is corresponding to the model of rain and snow, and this is the model of M of traffic, So the intersection part is basically the model of KB. Okay, so this intersection part is basically the model of KB. That's why we say that M of KB is the set of all worlds satisfying those conditions. M of KB is set of all worlds satisfying those conditions. So I hope it is clear that what we mean by KB. Now what we can say that if I try to, I will just explain it again like this. So if this is formula 1, that we saw, that is raining and snowing, okay, this is formula 1, and this is formula 2, that was traffic. Then if I draw the models of this, that means if it is M of F1, okay, so this is from syntax land and this is from semantics land, right, and this M of F2 is the model corresponding to the traffic, okay. So this is again here, this is from syntax land and this is from semantics land, okay. Now this intersection part is nothing but model of KB, M of KB, that is knowledge base. So adding new formulas is basically adding constraints to the model, right. Adding new formulas is basically adding constraints to the model. So what I am claiming is adding new formulas is adding constraints to the model, is adding constraints to the model, okay. But why I am making such an why I am making such a statement is, let us say I am adding a new formula F3, then if I draw a circle, draw a model corresponding to it, then the only part that will lie in the intersection of these all, okay, only part that will lie in the intersection of these three. Okay, so this part is in the intersection of F1 and F3, and this part is between the intersection of F2. So here is a constant, and only this particular part, this particular area, this area will get excluded. So only this area will be now my M of KB. So that means I am now restricting my model of KB. Okay, so I am adding constraints to the model. So this is what it means. Okay, now let us take one more example. Let us take one more example. We are given model of rain, okay, and I am given model of rain implies wet. Okay, so let us draw these things. So model of yes, this is model of rain, then model of rain implies wet. So how we can write it? Model of rain can be represented like this. Here if it is wet and here if it is rain, then model of rain means, see, this is 0, this is 1, this is 0, this is 1. That means there is rain. So corresponding to the one part, it will be shaded. We don't know about wet thing. It is not mentioned. Only mentioned that rain is 1. Now if I talk about rain implies wet, this means it is basically saying negation of rain and or wet. Okay, so if I draw this for rain implies wet, it will be 0, 1, wet, rain, 0, 1. So here it will be, even if there is even if either of them is true, then the output will be true. So if the wet is true, either it is 0 or either it is 1. If the wet is true, and if the negation part, that means if the rain is 0 and wet is 1, then the output should be 1. And if the rain is 1, okay, so if the rain is, let us say, 1, then its negation will become 0, and or we are having wet. So in such case also we will be having the output as 1. So it is mentioned here, this particular part. Okay, so now what we can see, that model of rain comma rain implies wet. So now I am trying to take these two formulas and then plot their output. So what it will be? It will be basically the intersection of these two. So this part is common in both of them. This part is common in both of them, and hence the KB, the model for KB or given model will be equal to, here it is wet, here it is 0, 1, here it is rain, 0, 1. So this part will be the model of KB, right? So today we saw about models, definition of model, and then we saw that how a model is basically a formula compactly represents a set of models. This we will see. So we can see here that this, whatever we saw through this diagram, is compactly represented through this formula, that rain comma rain implies wet. Okay, so thank you. In the next lecture I will discuss about entailment and after entailment we will, no, before that we will see adding something to KB, then entailment, and then there is contingency. Okay, thank you.